Okay guys, how are you? Now we analyze the residuals of our data set, right? The residuals is basically the difference between the points and the line that it's used to describe the behavior of the scatter plot and the points of scatter plot properly. Okay, so when we plot the residuals, we have this difference. Okay, so let's print model 0 dot a squared. As too much closer to the 1, it means that the model is very good explained by these variables, right? As much as far from the 1 or closer to 0, the variables doesn't have a good explanation relationship. So let's verify there was a problem. Okay, here are a square, right? So notice that when we associate the price with area, we have the a squared of 0.9. That means these two variables has a good relationship of explanation, right? Now, how I previously mentioned it, let's go to the residuals. Model 0 dot residue. Notice that it's possible to verify some differences that are negative, okay, and others that are positive. But in general, we need to understand that this is the difference between the points, right, and the line that represents the behavior of these points. And this is the best line, right? And despite the fact that these numbers have a bigger magnitude, okay, we have the best representation, okay. So let's see this in a histogram. Dot reset dot Este. Let's nominate it lt dot title. plt dot show. Okay, so we have this histogram to know. Let's okay guys, I perceive that I committed a mistake, right? Because I associated the price with the area m squared. So I just shifted the variables, right? The price will be the response variable, okay, and the area m squared will be the explanatory variable. That is, the area m squared will be the dependent variable, right? That will be in the y-axis. That will stay in the y-axis, right? And the price will stay in the x-axis. So the informations will vary because the intercept when the area m squared is because when the price increase in 1 unity, the area m squared increase in 9.85 meters square, okay? And the other variables are the r square is good, The residuals are very small now, right? 0.51, 2.32, minus 2.35, minus 1.73, and 1.23, okay? That we should hope, because this line, how I previously mentioned it, represents the best representation of this scatter plot, right? And due to this fact, when we must have a thinny, okay, a small difference between these 2 points, for example, okay. And let's continue. Plot the histogram. It is strange. This histogram doesn't show anything to us. Let's cut this. Okay, guys. So let's create a model, right, that will predict the y-axis. That is, that will predict the area m square from a price that are given a priori, okay? So y predict ticket. Let's use our model dot predict using the x test, okay? Okay, I just shifted the price to the area m square in the previous code, right, to verify the prediction. So let's to see its accuracy, right, and how it was good, we need to import the square, okay, square score from the sklearn matrix. So from sklearn.matrix import square score. Okay, so let's print this using let's print this using the f string, okay? F square square score. Let's put the two variables that we're taking into consideration to this comparison, right? The y test and the y predict. And now 2 points dot for f. Okay, let's go. 0.9. Okay, so the explanation, comparing the y test and the y prediction is too nearly, okay? These variables present results too nearly, right? And let's verify the linear behavior between the price and the other variables, has parking spaces, area m square, and total area, using the seaborn, right? Seaborn as sns.perplot. And let's go. First, you need to put the data, and after that, the y-verse. No, we need to shift to this way. Okay, upper right. The y-verse will be the price, and the x-verse will be total area, m square, area, m square, parking spaces, and neighborhood index. Okay, let's compile this. Positional argument keyword, total area m square, parking spaces, neighborhood index. Oh, I need to put the equal here. Okay, so here we have our scatter plot associating price with all the other variables. So notice that we have a linear behavior, how I previously mentioned, associating price with total area m square and area m square. And with neighborhood index, it's linear behavior approximate pretty much, right? And here in parking spaces, we have some sets of spaces that vary the price, right, despite of your non-changes. And I'd say that there is a moment in which the parking spaces doesn't really matter when associated with the other variables of the app, right? Now let's add factors in our linear regression model. Okay, so to it we need to use the OLS, the ordinary least square, from the Statsmodel, right? So import statsmodels.api as sm, xtrain equal sm.add constant xtrain. Okay, so we need to add this context to vary the we need to add this constant to vary the intercept, right? And add a non-linearity in our model, right? To decrease the bias in him. Okay, so we will create the model one. Okay, sm.ols y-train, and the x-train will contain const total area m square parking spaces, and finally neighborhood index. Okay, dot fit, and let's see this area m square, not an index. Oh no, because area m square is the y-train. I'm sorry. Okay, now let's put the price too. Price. Okay. So the summary to finally our class. Okay guys, in the next class we will analyze these results, okay, and realize some comments. Bye bye.